You may have been practicing on your own a little bit in this next section of problems. Let's go and see how you've done. So remember, we use addition and subtraction principles first when there's multiple terms on one side. So I've got the 2/5 n plus 5. So I'm going to take away 5, subtract 5 from both sides. And then I have 2/5 n equals a positive 17 and a negative 5, or 17 minus 5 is 12. Remember, when you have a fraction in front of the variable, the way to get rid of that is to multiply by the reciprocal. So the reciprocal of 2/5 is 5 over 2. So when I multiply 12 by 5 over 2, I'll simplify that in a minute. On the left side, I'll have n. That's just one n. Please remember, this is like 12 over 1. Also, just a reminder of some of your reducing work with fractions. When you multiply fractions, if you have a common factor, like a 2 goes into 2 once and into 12 6 times, then what you're left really is just 6 times 5, which is 30 over 1. So your value for n is 30 in this problem. Don't forget to check it. I'm not going to finish it all out, but what you do is you take 2/5 times 30, and you'd add 5 to that, and then you want to see if that equals 17. Actually, I can do that pretty fast. 5 goes into here once, into here 6 times. 2 times 6 is 12, and you ask yourself, is 12 plus 5 equal to 17? It sure is, check mark, and so I know I got this problem correct. Now, when you have two terms on one side of the equal sign that are like terms, you must combine those like terms first before you apply the two principles. So 6x plus 3x is just 9x. And then I'm going to divide both sides by 9 to solve for x, and I'm going to find out that x is equal to 6. So you got to clean up the two sides of the equal sign of the equation before you apply the principles. Now, when there are two terms on each side of the equal sign, you have four choices. I'm probably going to be erasing everything I do right now. So you see that 3 right there? One of your choices is to subtract 3 from both sides. You see that 6x that's there? One of your choices is to subtract 6x from both sides, because you want to get all the x terms on one side and all the numbers on the other. Another one of your choices is to take that 24, and to get rid of it, you could subtract 24 because it's a positive 24. See, right in front of this 24, there's nothing there, so it's a positive 24. So you could take away 24, but you'd have to take 24 away from the 3 as well. And finally, so 4 choices. Your last choice in solving this problem, any one of these choices would give you the correct answer. See this minus x? Your last choice would be to add x to both sides, and you'd put it under this 6x. Remember, that's a 1x you're adding. That's the one I'm going to do because for several reasons. I like to work with the x's first, and secondly, I like to make it so, if it's possible, that I can have the coefficient in front of the x term be a positive, and 6x and 1x is a positive 7x. I'll bring down the 3, and on the right side now all I have left is the 24 because I got rid of these x's. Now remember, you're trying to isolate the x term so that you can eventually divide by 7. But you don't divide by 7 until the end. So now what you're going to do is subtract 3 from both sides of the equal sign, and you'll have 7x equals 24 minus 3 is 21. And then finally you'll divide both sides by 7, and you're going to get your solution to this problem of x is equal to 3. Again, here's what my check looks like. So I'll take the original equation, which is 3 plus 6 times whatever x is. Well, x is 3. And then it's got to equal 24 minus whatever x is. X is 3. So I have 3 plus 18 equals 24 minus 3. The left side is 21. The right side is 21. So I know my answer is correct. Let's go to number 13. So see this minus 2x and this positive 5x? I'm taking this minus 2x and I will add 2x to both sides because I want to keep the x term positive. So on the right side of the equal sign, I'll have a 7x, and then I'll have that 7 right here that I have to get rid of. The way to get rid of that 7 is to subtract 7 from both sides. And then finally, now at the very end, when I have one term on the left and one term on the right, I said that backwards, I'm going to divide both sides by 7 to get my solution for x, which my x is equal to 1. And I will take that answer and put it back in the original equation and check it. Next, if I have some grouping symbols, I need to distribute and clean those up before I use any of my principles as well. So 9 times 5 is 45y, and 9 times a minus 2 is a minus 18. I want to isolate that y term, and that y term is right here, and it's got a minus 18 hanging out with it. So I have to add 18 so that those will go away. So therefore, come on over here and add 18. So let's see, 15, that's 45 equals 45 times y. So now and only now do I divide both sides by 45, and I find that y is equal to 1. You know, write it like this or write it like this. It doesn't matter. Let's go to a few more problems with, see if I can get, there we go. Let's go up here and distribute the minus sign. So I've got this, I want to subtract what's in these parentheses. Remember, that's like multiplying what's in these parentheses by a negative 1. So I have this 8x, and this negative 1 times 3x is a negative 3x, and this negative 1 times a negative 5 is a positive 5. Or just change the signs of those two terms. The 3x became negative, the minus 5 became positive. And now, please notice that on the left-hand side of this equal sign, there are two terms that are like terms, so they have to be combined. So 8x minus 3x is 5x. And I'm getting closer and closer all the time. So at least I have just one term with x in it. Now to get rid of the plus 5, I'm going to subtract 5 from both sides. Notice the equal sign right here. I'm subtracting 5 from both sides of this equal sign. This is the process of keeping the equation balanced, is what it is. So 40 minus 5 over here is 35. And now I divide both sides by 5, and I find out that x is equal to 7. Again, please remember, supposed to come back here and put a 7 in, right there for x and right there for x, and then use order of operations. I'm going to see if I can fit that a little bit. So I'm not going to probably get it all done. So 8 times x, where x is 7, minus 3 times x, where x is 7. And I've got to do what's in the parentheses first. So I've got to do this 21 minus 5, which is 16. And then way over here, I have 8 times 7 is 56. So 56 minus this 16 is what that is. 56 minus the 16 is indeed equal to 40. And that was kind of a sloppy check, but I can tell that it did work. So please do your checks every time. Let's see if we can get a few more done. So 3 times 2 is 6. 3 times the minus 3x is a minus 9x. 7 times x is 7x. 7 times 1 is 7. On the right-hand side, I have to collect these like terms. 7 take away 33 is minus 26. And then now I've got two terms on each side. Two terms over here, two terms over here. So I personally am going to choose to add 9x to both sides because that will cause this right side to have a 16x. So I love to keep that coefficient positive. And then I have to add 26 to both sides. So it looks like I'm going to have a 32 on the left. And then I'm going to divide at the very end both sides by 16 to find out that x is equal to 2. How about if you go ahead and do the next two, but let me just tell you that this one's answer is going to be 0, and this one's answer is going to be no solution.